All right, folks, so now that we have gone over how to solve rational equations, we're going to work trying to solve some rational inequalities. We'll notice some new patterns that we need to go through, a little bit of a new procedure as we work through, but for the most part, the process, the approach is going to be very, very similar to what we covered in section 5.4. So here, let's take a look. First, we have, just to warm ourselves up a little bit, we have an equation to solve. It's not an inequality, it's an equation because we see the equal sign right here in the middle. Luckily, we know how to solve equations. We start off and we state any restrictions. Okay, my variable is in the denominator. It doesn't have anything along with it, so simply my variable cannot equal 0. Good, so I have the restrictions out of the way. Now I need to try and find a common denominator. Luckily, only one of these terms right now. I have 3 terms, only one of them is a fraction. It has an x in the denominator, so very quickly my lowest common denominator, if you will, is simply x. All right, if my lowest common denominator is x, then I need to make sure all of my functions have that there. I can multiply, I can divide my left-hand side by x. I can multiply it by x as well, so I'm working with x minus 2 right here. And on my right-hand side, still 8 over x. Good. Now, I apologize, folks. I'm recording this video from the school, as you can hear. Now that I've finished that, okay, I know how to work forward from here. I can cancel out my denominators. Once my denominators are canceled out, I can expand in my numerator. That is, I'm working with just a quadratic problem, right? X squared minus 2x equals 8. I know how to solve something like this. I move everything over to the left-hand side. X squared minus 2x minus 8 equals 0. I factor what's on my left-hand side here. That is x minus 4x plus 2. And since that equals 0, therefore my solutions come from each factor here. X can equal positive 4 or negative 2. Good, nice, and easy. Now let's try a similar approach over here. We can try to solve where x minus 2 is less than 8 over x. Okay, so it's a very similar setup. Obviously, the difference is now we're working with an inequality instead of an equation. So we'll try and set it up the same way. All right, so we know x is not allowed to equal 0, because if x were to equal 0, we would be dividing by 0 at one point. We're not allowed to do that. So we have our restrictions done. Now we try and find a lowest common denominator. Again, we multiply the left-hand side by x over x. So we're working with x times x minus 2 divided by x, where that is less than 8 over x. Nice and easily. All right, we can handle this. Here we can cancel out our denominators because it shows up on the left-hand side and it shows up on the right-hand side. And since my denominator shows up in both of those spots, once it's canceled out, I'm working to try and find where x times x minus 2 is less than 8. So I can, again, expand this. I can bring everything over to the left-hand side. I can write this as a quadratic where x squared minus 2x minus 8 is less than 0. And I can factor that even further. Well, I can factor this here just like I did last time. So x minus 4x plus 2. So I'm trying to find where this quadratic is less than 0. I know how to do something like that. If I wanted to, I could just sketch it. So I have a root at x equals 4. I have a root at x equals negative 2. And we'll try and get through this with as few interruptions as possible. My quadratic here opens up. And again, you could be doing this with a number line or with a quick sketch like we are doing right here. And we can see from this quadratic opening up, we can see that this function is less than 0 in here, in between x equaling negative 2 and x equaling positive 4. So that means my solutions, nice and easy, nice and straightforward. Therefore, therefore the solutions are, where x is an element of, and we can write this in interval notation, from negative 2 to positive 4. Fantastic. Now, the only problem with this approach is if I graph x minus 2 right here, and that's graphed in blue. X minus 2 I have graphed in blue. X minus 2 is the left-hand side from here. And I graph 8 over x. And looks like it's graphed in red down here. I have 8 over x equals 8 over x. I have them graphed. Then my function x minus 2 should be less than the function 8 over x only in between negative 2 and 4. And I'll say that again. My function x minus 2 should be less than 8 over x, because these are the solutions that we just found, only in between negative 2 and 4. And in fact, maybe we can bring this in as well. Remember, x cannot equal 0, so maybe we should have adjusted this solution between negative 2 and 0 and positive 4. Right, so we need to be careful. Well, if I look down here, that's not the case. My blue function is less than my red function. Oops. My blue function is less than my red function over here, up to the point where they intersect at x equals negative 2. And my blue function is less than the red function as well. Here I can see it's greater than the red function, but it is less than the red function after I cross x equals 0. Right? Again, my blue function is less than my red function because my red function has that asymptote there. It goes from negative infinity to positive infinity, really, over the asymptote. So for this small part of the function as well, so really my solutions that I'm finding, if I try and solve this graphically, I'm finding all the way up to their point of intersection here, and in between 0 and their point of intersection there. So there is the solution that I'm finding graphically here, it differs from the solution I found algebraically. The solution I'm finding graphically is between negative infinity and negative 2, union with from 0 to 4. Right, so we can see right here clearly something about our approach up here had a problem in it. So really, we need to be careful. This was not a very good approach. This was, in fact, wrong. We need to try and adjust our approach to be able to handle it so that algebraically we could find this kind of a solution. Well, let's take a look in here at any part where we really changed the problem, and that is where we canceled out our denominator. We canceled out our denominator x. Well, in inequality, we need to be careful. If we're choosing to divide a side by x, or to multiply both sides by x, because really that's what we're doing. We're multiplying both sides by x to cancel out these denominators, right? When we chose to cancel out those denominators, if x is a negative number, then we would actually have had to switch the inequality sign. You might remember that from section 4.3. But x might be a negative number and it might be a positive number, so we need to be careful. We need to find a way to track our way through this problem without while being able to keep track of the direction of our inequality sign. So you'll see as we go through, we have a bit of a new one, so we need to be careful when we're solving our inequalities. We can follow a similar procedure to the one we followed solving rational equations, but we cannot cancel the denominators when we work through the solution, because when we try canceling the denominators, things all go haywire. Things go off in a way that we cannot track as we work our way through. So let's look at an adjusted procedure, because we had our procedure in section 5.4. We'll adjust it here. First, we rearrange the inequality so that one side is 0. Okay, and then we want to find a common denominator and simplify. Once we simplify here, or once we find a common denominator, we are not allowed to cancel the common denominator. Then we want to fully factor and simplify. We've been doing that for a long time. I want you to think about this after we work our way through. You can come back here and try and think to yourself, okay, why are we allowed to cancel common factors? And then we can use a number line. All right, to find our solutions, we will need to rely on a number line here, or you'll hear it called a sign chart from other teachers perhaps, but we're all following the same kind of logic here. So we'll try it out with a new one here, and we will try to handle this in a way that allows us to solve it well. So we want to try and find where this function is positive and where this function is negative. Where it's positive or where it's negative. We want to find an answer to both of those questions. Okay, so we have our function, and let's say we're trying to find, we'll work with where it's greater than 0. Or rather, you know what, not even yet. Let's just rearrange the problem a little bit first. Okay, so we have x squared minus 4x minus 5. If we are trying to find where this equation where this function is positive or negative, then effectively what we're trying to find, what we can do to simplify it right off the bat, is we can factor it. Okay, well then that's x minus, let me see here, x minus 5x plus 1 in my numerator divided by x plus 3. Okay, so it's our goal to find where this function is positive or negative. If we're trying to find where this function is positive or negative, let's try and create a number line right off the start. So no, we're not going through this whole thing. We'll go through this whole thing as we reattempt the first problem later. But here we want to create a number line. We have our function right here. You have been handling number lines with these rational functions already. When we create a number line, we have to use roots, which come from roots of the numerator. So my roots will be at x equals positive 5 and x equals negative 1. And then we also need to remember to use here roots of the denominator, because those tell us our vertical asymptotes, right? So at x equals negative 3, there's a root in my denominator. So on my number line in here, I need to try and find a test value for each of these intervals. How many intervals do we have here? Think about it. Good. If you said 4, you're correct. We have one interval here, one interval there, one interval here, and one interval here. So my first interval is in between negative infinity and negative 3. My second interval between negative 3 and negative 1. My third interval between negative 1 and positive 5. And my last interval between positive 5 and infinity. And I need to check each of these intervals to determine where my function is positive and where it's negative. I will encourage you here to pause the video, try and complete your number line on your own. You should be able to do this because we've been working with number lines for quite a while now. Okay, so pause the video here, try and fill out your number lines, and then unpause it and come back to see how you did. Good, and you should find here that your function is negative for the first interval here. And we will, there we are, sorry. It's negative for this first interval here, it's negative for the second interval here, and it's positive for the other two intervals. Right, so just creating that number line, again, that's practice, that's straight from our problems before in section 5.3 when we started looking at the number lines of our rational equations. Now we're just practicing it, and we're going to work with it to solve our inequalities. Okay, so let's get down into this inequalities problem once more. Okay, so we have this inequality. Now we want to rearrange this inequality so that we're working with here just like from our procedure at the top of this page, we want to rearrange it so that one side is equal to 0. Okay, well we can do that. We can just subtract 8 over x from both sides. All right, so we're working with x minus 2 minus 8 over x is less than 0. Fantastic. Well, from here, we want to again work with the lowest common denominator, just like we found before. My lowest common denominator should be x. All right, so that means I'm working with x times x minus 2 minus 8 over x, divided by x over here, less than 0. And from here, I can combine all of my, sorry folks for the zooming, I will figure this out, I'm sure, by the end of making these videos. From here, I can combine these into a single fraction, right? They have the same denominator. I can combine them. So that is x times x minus 2 minus 8, all divided by x. And again, I'm solving this problem in my numerator, just like we did when we were solving rational equations, but this time we're keeping track of our denominator. So I'm working with x squared minus 2x minus 8, all divided by x, and then factoring it like I have before, x minus 4, x plus 2, all divided by x. And I can see here, I'm trying to find where this function is less than 0. Where this function is less than 0, I know this function has roots at x equals 4 and x equals negative 2. I know this function has a vertical asymptote at x equals 0. Okay, so then I can come up with a little bit of a sketch if I would like, or rather into a number line, right? Into a number line. Okay, so I have x equals 0 right here. I have x equals positive 4 there. I have x equals negative 2. So I'm including my roots and my vertical asymptotes into this number line. Once again, I'm solving this number line. I'm trying to find answers for 4 different intervals here because I have 3 different either roots or vertical asymptotes. Again, I will encourage you, pause the video here, try and solve your number line, try and come to a conclusion for this problem, and then unpause it here to check your work. Good, so we should be able to see here that our function is going to be less than 0, that's what we're trying to find, right, where it's negative, and that is in the interval from negative infinity to negative 3 here, I can see that it's negative, and from the interval from 0 to 4, I can see that my function is negative. So all of a sudden here, my solutions should be therefore from negative infinity to, to negative 2, union with from 0 to positive 4. And you can see, so we solved this algebraically. We did not use any new skills here in this course. We just put some skills together from different sections. And we can see that we came to the same conclusion that we found graphically up above. Right? Graphically speaking here, we said, okay, well, this red function was, or my blue function was less than my red function between negative infinity and negative 2 and between 0 and 4. Now, from this point, honestly, you might benefit from seeing one more here. So let's try going over one more. I did skip over a little bit of a problem as I went through that, but it should not have affected our work in there. So let's try, we'll call this example, I think 3, example 3. And we'll work with solving x divided by x plus 7, trying to find where this is greater than or equal to negative x divided by x minus 2. Okay, so first we rearrange this so that one side is equal to 0. One side is equal to 0. Here it doesn't matter if you're working on the left or if you're working on the right. What we can do here, oh, and you know what, before that, let's, sorry folks, we can even call it step 0. State restrictions, right? We should be stating those restrictions as we found in section 5.4. Okay, so we'll work in blue. We're stating the restrictions. We know here that x cannot equal anything that would make our denominators equal to 0. So that means x cannot equal negative 7 and x cannot equal positive 2. Good, we've stated our restrictions. Now we want to rearrange it so that one side equals 0. Okay, well then I can subtract this, or I can, add this fraction to either side. So I'm working with x divided by x plus 7 plus x divided by x minus 2, where this is greater than or equal to 0. Okay, so now I've set one side equal to 0. Now what I'm looking to do is find a common denominator and simplify. A common denominator and simplify. Okay, we know how to do that. This is pretty straightforward. Again, if you were struggling, like I mentioned in class yesterday, if you are struggling to handle this, I just want you to Google common denominators or find, search that up on YouTube. You should be able to work with it. Okay, so my common denominator here, my lowest common denominator, should be x plus 7 times x minus 2. There's no need to expand this here. We can work with this in factored form. In fact, it's a little bit more useful to us right now in factored form. All right, so my first fraction here, I'm going to multiply by x minus 2 divided by x minus 2. All right, times x divided by x plus 7. My second fraction, I'm multiplying by x plus 7 divided by x plus 7. All right, times x divided by x minus 2. Nice and easy. Okay, well that means then that I'm working with, and I'm going to handle a couple steps in one line here. Okay, so I'm going to write the whole thing over a common denominator, and that is x minus 2 times x plus 7. And in my numerator, I'm going to expand in, right? So I'm multiplying x times x minus 2. Well, that's going to be x squared minus 2x. And then I'm expanding this in over here as well. X times x plus 7. Okay, well, x times x is x squared. Oops. X squared plus 7x. Good, and now I can simplify this. I can expand, or sorry, I can collect my like terms. I still need to keep track of my denominator. right? I'm not able to cancel this time like I was able to in the past. In my numerator here, I have 2x squares plus 7x minus 2x, so that's plus 5x. Okay, fantastic. Well, from here, now that I've found my common denominator and simplified, I need to factor with where I'm working, right? So I need to fully factor as much as I can, fully factor. And at this point, when I fully factor, I can simplify if I want. Simplify. I am able to cancel any common factors from the numerator and denominator, and those would represent any wholes. But at this point, let's see here. So we factor it. We're working with x times 2x plus 5 in my numerator, and in my denominator, x minus 2, x plus 7. Okay, good. I don't have any wholes here. I don't have any common factors. But what I do have, and I want you to break this down, maybe pause the video if you would like, I want you to list off any zeros and any vertical asymptotes. Okay, so my zeros here should be at, my roots are at x equals, I'm working with 0, and I'm working with negative 5 over 2. Okay, my vertical asymptotes are at x equals negative 7 and x equals positive 2. Fantastic. So now I'm coming up with a number line. Remember, I'm trying to keep track. What I'm trying to do are find x values that solve this. And what will let me get there is to create a similar function, which I did over here. A similar function, but where the inequality is greater than or equal to 0, because I know how to find roots and asymptotes. I know how to work with the number line there. So my vertical asymptotes, my roots, I put it all on one number line. Okay, so my vertical asymptote, negative 7, my root, negative 5 over 2, my root 0, and my root 2. So how many intervals am I working with here? Should be working with 5. You know how to handle a number line like this. I'll pause it. I'll show the full solution in just a moment here. Good, so we can keep on working right here. Now you should have found that your function is going to be greater than 0 in between negative infinity and negative 7 here, in between negative 5 over 2 and 0 here, and in between 2 and positive infinity there. Now this time, though, we need to be careful. Our solution is not, whoops, you know what? It looks like I got a little bit lazy as I copied these down. My inequality sign changed here. See that? Let's try and fix that. My inequality sign should be greater than or equal to, right? So when I try and write my solution here, I know, okay, so and I'll write it up here so that you can see the work a little bit more. So therefore, where x is an element of, and we can go with from negative infinity to negative 7, union with from negative 5 over 2 to 0, union with from positive 3 to positive infinity. But then we need to ask ourselves, we need to double check. Okay, well, hang on. What we're trying to find here is where our function is greater than or equal to 0, right? So we need to include any of the points where our function equals 0, right? Well, hang on. Those ones, is that going to be at all of these endpoints? Think about that for a moment. Will it be at all of these endpoints? Absolutely not. It's only going to be at the endpoints that come from our roots. So at x equals 0 right here, and at x equals negative 5 over 2 right there. So we need to include in here, only at those points, we need to include those endpoints in our solution. Fantastic work. At this point, folks, you should be able to handle the rest of the homework. I may post a full solution. You know what, I'll give you here, I realize it's getting long. I'm not going to go through the full solution, but I'll give you another example with a full solution there. So example 4, solving where x cubed minus, and this is a little bit of a challenge problem for you, because it's really relying on many of our previous skills. X cubed minus 2x squared minus x plus 2. All divided by x cubed plus x. And you're trying to find where this is less than or equal to 0. Okay, so this will be included, this solution will be included in the note that gets uploaded, but I won't go over it here in the video. At this point, you should be able to handle all of the homework.